Welcome to JFix and a special series for my channel. I have made the stupid decision to buy 20 faulty laptops in a job lot from eBay. We don't know what we're going to find. Being from a job lot, they've probably been worked on before, they've not been able to be repaired, and they've been sold as a job lot. So fasten your seatbelts and join me on this roller coaster ride as we try to diagnose and fix as many of these 20 we can in 20 episodes. Here we go then, laptop number 3 out of this job lot of 20, and we've got something a bit different now because I've done 2 Dell laptops and now we've got a HP. So this is the HP ProBook 450 G6. So I'm not sure what CPU and what specs this laptop is, but just feeling it, it's a really nice laptop. This is all metal on here. And I think it's a plastic base, but yeah, this is like a metal top, and there's no dints on this at all. It seems to be in really nice condition. Might just need a little bit of a clean up in this corner, but yeah, it's quite a nice one. In terms of ports that we've got on here, over this size we've got a lock, and we've got a USB port, probably USB 2, and we've got a SD card reader, which is always nice. Over on this side of the laptop, we've got a couple more USB ports, full-size HDMI, we've got a nice LAN port, and we've got a USB-C port. Now, the USB-C port does say D on there, so I think that means it's display compatible, so you can plug an external monitor in using the USB-C port. I'm not sure if it takes USB-C power though or not, because it does have a separate power jack here with an LED as well as the headphone, as well as a headphones jack over here. And we do have a HP ProBook. We've got a product ID and a serial number, and over here it confirms it's 19.5 volts in with 2.3 amps. So let's take a look inside this laptop. Not actually opened this yet. Well, that's a shame. We're missing a key here. That's missing. That will be the E key, which probably isn't an issue. Could get that. And I've got a hole here. I'm guessing that's where the fingerprint reader goes. So why that's missing? Either it's been pushed down and popped out, or somebody's been in this before, which is quite possible. Let's turn it on and see if we've got any juice. Powering on. No signs of life. Let me prepare a power adapter. So I do believe that we can actually use the Dell power adapter for HP as well. Right, my power supply is on. You can be able to see that in the top right corner. And we've got 19.5 volts. So let's plug in and see what current draw we get. Here we go, 31, 30, and back down to 9. I really hope we've got a nice interesting fault on this one, because the other two have just worked basically. So we've got some current there, so that's good. Maybe it's powering up our EC chip. Let me press the power button, see what happens. Ooh, looks like no response. Try again. Yeah, holding it down. No response at all. Unplug it, plug it back in. Yeah, we're not getting any sign of life out of there. So it is drawing a little bit of current, but it's not charging current, it's not charging the battery, and we've not got anything on the power button. So this is definitely going to be one we need to open up, and I can see already, actually, screws have already been removed, and, oh, that's weird. What we got in there? Some kind of dodgy Torx screw, which sits proud of the motherboard. That's strange. So I'm going to need to see if I can find something to get that Torx out. It's only hand tight actually. That is not a laptop screw bit with thread locker on it as well. What's that doing in there? Oh, this is why it's a roller coaster ride. Could be interesting, this one. I hope so anyway. Well, definitely this is the first laptop that hasn't turned on, so quite happy about that, and hopefully we're going to have an interesting fault. Okay, and the cover is off. Well, we have a motherboard, so that's a good start. Motherboard is there, and we've got memory that hasn't been taken, so that's quite interesting. Right, Wi-Fi card is not there. Let me zoom you in a bit. Yeah, you might be able to see better now. The Wi-Fi card has been taken because that would connect into there. So someone has been in here. Got a bit of a strange setup on the battery here. Is that a genuine battery? It seems to go into there through a daughter board to the main one. So maybe that's a HP thing, I don't know. First time working on it. Where's that fingerprint sensor then? Oh, it would go in here. So we've got a hole here. I'm not too sure about that. Maybe there was a daughter board that's screwed in there. Strange. So we've got our USB-C put there. Our DC in comes in here. And there's a little cable that connects to the motherboard there. So let me just check that my adapter's good and that we are getting power into the board at that point. Let's take a measurement here. Yeah, we got 19.5 volts going into our motherboard, so that's good. Oh, wait a minute, we've got something. We've got a light here. I just need to see if that's a blink code. I didn't notice that before. So, 1 long, 2 long, 3, 4, 5. Am I just going to be counting forever? Okay, so maybe that's not a blink code. Maybe that is just indicating whether it's charging the battery. Let me just go on to the battery connector now, because it looks like we've got quite easy access to this. And let's see what's going on over there. So we'll go from here to here maybe. Right, 0 volts. Here to here. Right, we've got nothing on our battery. So maybe that battery is locked because there's an issue on the board. Just wondering if there's any measurements we can take without actually having to take the board out first of all. Go with the easy things first. Everything seems to be under these shields. But we have got access to some power rails up here. And we've got some diodes there. Or is that a tantalum capacitor? Can't see with my eyes. Well, we've got a big fuse here for the screen, for the backlight. Let's see if we've got voltage on there. Should have 19 volts on that fuse. Yep, we've got 19.5 volts on there. The other side, so we've got main power rail on our backlight. I'm just not really seeing anywhere to measure very well here. I'm just going to double check, see if we've actually got any caps lock, because that was one thing I didn't check. If we've got an error, I think there might be an error code on the caps lock. Oh yeah, hang on, I've got something flashing here. Right, dim the light so we can see that. So we got 1, 2, 3, 4, 5. So I'd say we've just got steady blinking. It's not really an error code. We've got steady blinking on the power light, and we've got steady blinking on the caps lock key. Right, I can't get to anything to measure it that well, so let's just go with the simple things first. Let's reseat the memory. In fact, we can do one better than that because we've got 2 slots. Let's move that over to this slot just in case. And let's disconnect the battery to reset the BIOS. Okay, our battery is out, and I can see we do have a backup BIOS battery here, so let's unplug that. Why did they put that on the underside of the board? In fact, before we put this battery back in, we better just measure it, hadn't we? Let's see if it's dead. Yeah, there we go, we've got a dead battery. 0.2 volts. So is it going to be funny and not want to boot when it's got a dead battery? Maybe we just take that out. Let's see if anything changes when we boot without those 2 batteries in. I can't imagine anything's going to change, because if we've got 0 volts on the main battery and 0 volts on that coin cell, then there's no voltage on there anyway that would have been doing anything. Pressing the power button, still nothing's happening, yeah. So I'd say our main power rail is present, just because we're also seeing 19 volts over at the screen connector. I'm thinking we need to check for our 3.3, make sure we've got power button at the switch, because we're getting no response from that at all. Let's keep things organised then. So this is the battery, and I'm going to keep the screws as I go. I'm going to remove the CPU heatsink. Probably be a good idea to start with a good visual inspection as well on this. Now that comes out nice and easy. Thermal paste is completely dry. Thermal paste is completely bone dry. That's not good. Look at that. That's solid. Same on the CPU, it's also solid. I think it's going to be easier to work if I have it this way for the microscope, and we can measure some voltages now. In fact, let's just measure straight off. I think you can still see that. So, I think we had something there. We've got 1 volt on that coil, and this one, we got nothing. I can't even see an EC chip on here. Alright, actually let's just take the board out and then we can do a full inspection. So that's our screen. And our motherboard is out. Oh, here we go. We've got a Novaton EC chip down here. We have the MPS chip for our PWM for the control, CPU control. And we have our motherboard model number DAX8JMB16E0 revision E. I've recovered the DC jack from the motherboard as well, so we're able to plug that in. Right, microscope time. So I'm starting off my inspection around the DC jack, and under the microscope I can already see we were a bit crusty around here, so that's not actually very good. Right, let's get the magic nano sponges on the go, see if they can clean up. Might need a toothbrush to get between those gaps. Yeah, we'll use a toothbrush over here as well. Let's dry that off a little bit in that area. Okay, what's going on with these resistors here? Get my little pick on this. Just looks a bit crusty. Okay, so I think we're okay there. Right, so this area should be fine now. Let's just carry on with an inspection. Just do a quick one and we'll see if we notice anything. So we have here this APW chip. So that's creating a power rail. And we have a couple of MOSFETs on there. Is that maybe our charging coil? Don't think so actually, because it's not near the battery. Okay, I think that's just glue, by the way, from the sticker that was on the top. Might have a slight bit of yeah, I don't know if this is a bit of, you can see a patch around here and around this area, so I'm not sure if that's had liquid damage actually. Possibly. So this must be our power for our CPU. So we got these MOSFETs here and MOSFET drivers. That one for there, and this one for here. Right at the edge of the board we've got a little IC here. Nothing to worry about. RAM socket. How's the soldering looking on that? Possibly okay. Anyway, I don't think at this point it's worth looking at the RAM because it's not even powering on. So here's our battery connector. And if yeah, so we've got a big coil there, and under this foil must be our charging for our battery. Yeah, here we go. We've got our BQ chip here and a couple of MOSFETs. So this BQ is our charging IC. So over to the left of this BQ chip, we've got another few coils here. So we've got 1, 2, 3, 4, all different circuits, and yeah, I don't know what these are controlling. Slot for our NVMe, hard drive connector. Nothing much to see here, and that's going to be our chip that controls the LAN port, I think. And then we're back to the battery connector. Flip the board round. So we have here a Realtek chip right next to the headphone jack, so that's obviously going to be our audio. Can't imagine any problems here. And yeah, we got our USB port here with a little switch. Another USB port. So our EC chip doesn't look like it's blown out anywhere from what I can see. And looking around, everything seems quite clean over here. We got another Realtek chip. Infineon here. Not sure what the Infineon chip's purpose is. And we got another MOSFET on the back side of the battery connector here. So still just trying to get familiar with the board. There's not much else going on until we get to here. We've got our MPS chip for our PWM that we mentioned earlier. Okay, I found the BIOS chip. It was just under the Wi-Fi slot here. Does look a little bit crusty over here as well. It's always a good thing to check if the BIOS chip looks like factory solder or not. Then you know someone's been programming. I'm thinking that's a bit of water damage around there. That's not factory, is it? Right, let's just clean that up with the nano sponge again. And the pins on this SPI chip. Oh, it's quite stubborn. Let me get the tougher brush on that. That's really stuck on. I want to see if it's corroded away at the tracks. Let me get my really stiff brush on it. It's really not wanting to budge. Gonna have to go with a scraper, I think. There we go. We've got movement. So I don't believe it's caused any damage to the traces. I think we're okay there, whatever caused that. And our BIOS chip, not too sure. Could be factory solder. Oh, we have a CYP chip here. I keep finding new things. And we got this big chip here. But looking at this, where our power connector comes in, it looks like we've got our input circuit here as well. It's going to go through these few MOSFETs. Can't see where our current sense resistor is. Right, I've powered on my board and I'm thinking I'm going to go to the keyboard connector here because we should have our 3.3 on the keyboard connector. Let's just make sure, yeah, we've still got our 19 volts, just checked at the display again. So usually on like pin 1 or something, we should expect 3.3. Nothing on there. Maybe this is pin 1. Oh, we've got a 3.3 somewhere. Yeah, we've got a 3.3 on pin 4 there. Okay, it's actually on pin 5. It's got 3.3 on there and there. We've got 3.3 in several places, so that is our LDO 3.3. So why are you not responding to the power button? Right, I've just noticed I've got a different type of blinking on there. See that? 1, 2, 3, 4, off. 1, 2, 3, 4, off. Okay, so that wasn't happening before. Now we've got this motherboard out, I've just realised, because I've seen that it did have the Cypress PD controller in here, so as well as the barrel jack, we do also have a USB-C port, so this laptop should also be capable of charging on the USB-C port. Now, I have already plugged it in, and watch what happens when I plug this in. Look at the current in the top of the corner. So you can see it negotiates to 20 volts, and look at the current draw. We're drawing 179 milliamps on there, so that doesn't seem right. The CPU is not on, that's stone cold. So we've also got a flashing light code. You see, it goes to a solid white, and then how many blinks was that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I think it's 9. Either 9 or 10, and then a white light. But I'm not going to look up that at this point because I'm interested, where are those 179 milliamps going? And they're not going to be able to hide from me because I do have thermal cam. Nothing can escape Mr. Thermal Cam, so straight away I'm going to hold my phone up here. I've only just got this, I haven't set it up yet on the PC, but we have a hotspot here. CPU, it's just reflections, but look at that. That's not right on standby. So, out comes the macro lens. It's somewhere around this area here. I've already put the macro lens on, so let's check together. Look at that. So that little IC there is definitely getting hot. Shouldn't be doing that. Here I'm looking at the underside of the chip. Have a look at that there. So I think that's actually the heat signature from the chip heating up, and not one of those capacitors on there because it's quite dispersed on there. Yeah, I definitely think it's that chip there, and I'm thinking it might be like a load switch or something. So let's get in on that on the microscope. And this here is the chip that was getting hot under the thermal camera. Not good. So let me see if I can zoom in and get a clearer shot of what that is. So here it is then, it's the AYJK, and it says 532 on it. Now, looking at it closer, it doesn't appear to be a load switch. I think this is probably going to be a MOSFET driver, because here it is, directly above a MOSFET, and then a coil, and I think this is powering the CPU. Let me just zoom you out a little bit more. So yeah, zooming out, we can see here, we've got it replicated 3 times. So here looks like 3 drivers for 1, 2, 3 MOSFETs, and then we've got 1, 2, 3 coils. This one looks like a smaller coil than these two here, so also it's got a different MOSFET, but it appears to be the same driver that's driving that. So potentially this chip could be faulty. So looking at this MOSFET here, if we check the output, it's here that goes to this particular coil, and if we also check on this side, you see that? It's not shorted through. So I believe that this MOSFET actually is fine. You see, it just goes for a second, but there is no short on that MOSFET. Between what I believe is gate and source on there, no short. Drain and gate, no source. I'm not sure because I think this might be a dual MOSFET, as I say, so no short there. So I believe that this section all seems fine, and that this component itself, it has internally failed because it's heating up. So now we have identified that that little IC is heating up. How do we know what that IC is? Well, I'm very glad you asked. Let me just show you a picture up close. So it was the AYJK. We'll keep this image on the screen, and I'm going to show you something now. Okay, so what I'm going to do is I'm going to open up the JFix laptop IC database, which is the project that I've been working on. And in here we can see we've got a search function. So in there I will just start typing the marking that I can see on the chip, A, Y, and as I'm typing it, it's filtering the results. So I can already see AYJ, and here we go. We've found it straight away. So we've got all the details that we need for the chip very easily and quickly by finding it in the database. So we can see that this chip is manufactured by Monolithic Power Systems. It's an MPS chip. We've got the full part number now, so if we need to go ahead and order it, we've got this MP8693GDTZ. The package size, we know it's a TQFN12 package, and it's a MOSFET driver, which is exactly what we was expecting because it's just before that dual MOSFET there for the high side and the low side switching. And you can see here on the main chip marking it says AYJ, so they're the identifying marks that we need to know for this chip. But you might have full marks on here, examples like AYJK, like our example, or AYJJ, AYJF. They're all going to be compatible with each other because the last letter is actually like the year of manufacturer. So if we go across on here, we'll be able to see a description. So we can see it's a specialized integrated circuit manufactured by MPS, designed for high efficiency power regulation. That makes sense. We can also hop in here and see some images of the chip. So we've got here an AYJJ and an AYJK here, and you can see the pads on how it is underneath. And also, if you want to look at a data sheet, I've got them in here. So this is quite an important section. Now, this particular chip doesn't have a data sheet readily available to the public on there, so it's very difficult to find. But I have found all the information I can get about this chip, and I've put it in a text file, so we'll be able to see that in a text file. But as well as that, I've got a PDF file here. I'm going to do these for any chips where data sheets are not available. I'll download the PDF. And as you can see in the PDF here, what we actually have is a snapshot from the schematic on here. So we can see this is the MPS 8693GDT, and here we go, we've got a pinout now, which is going to be really useful of that chip. Let me zoom in a bit. So as you can see on this pin here, we've got pin 9 is switching the low side MOSFET going over to here, and pin 12 is switching the high side on the gate of that MOSFET. And obviously we can see that the other requirements that the chip requires, like plus 5 volts, is obviously the VCC, so it's powered by a 5-volt rail on here. And then we've got the various other signals on here, like a synchronization, temperature, PWM, and a CS as well. So yeah, this is going to be super useful, especially if your schematics are not available for the laptop that you're working on. You're now going to be able to look up the chip and reference it using a similar schematic from another board, because it doesn't matter really which motherboard you're looking at the schematic for. The chip is always going to be exactly the same pinout. So that database is my working project that I'm working on, and I'm getting there with trying to add chips in very slowly, but it will take a long time. But I have gone ahead and I've ordered the chips on here. So we've got, what, 5 is that in the pack? That's why it's taken me a little bit longer to release this video, because I had to wait for them to arrive. But let's switch over to the microscope and see what we've got. So you can see they're not AYJK, these are AYJM, but that's fine, that's compatible because it's just a month mark at the end. So we've got a few of them, and I think we should try giving one of these a go, soldering it on the board. Okay, let's remove one of these ones then. AYJM. Lovely. I'll probably set that off to the side so I don't blow it away. So we can just do a quick check, and it looks to be exactly the same physical package size on here, so that's good. Let's just check about pin 1. Yeah, so pin 1 is going to be indicated by this dot here, so it's going to be top left. So we just need to make sure we put the other one so the writing is going to be basically facing the same way. Right, I've got the hot air. Let's see if we can get this out. Hopefully we shouldn't need any flux on it to at least remove it. It's quite cold in my garage today, so might need a little bit of heating up. Start to see bubbling flux coming out of the MOSFET. Nearly there. And we've got it. Okay, in with the new one. Let's flip it over. And I think we might tin this up first as well, just to get a bit of solder on the pads. Let's add a bit of flux to this thing. I accidentally muted my microphone at this point, so I'm just talking over it now, and all I'm doing is just quickly tinning up those pads, so hopefully the chip is going to solder correctly to the board, and that looks okay. And now I've just applied a little bit of extra flux over to where we're going to solder it, help it to solder down properly. And I'm getting it in position, and we'll bring in the hot air and we'll try and solder it down now. And after soldering it in place, I did apply a little bit of pressure down and hold the pressure until the solder solidified. Hopefully each pad will make a good contact, and then I can come in and do a quick inspection, see how that's done. I'll use the nano sponge with a bit of alcohol just to clean up so we can inspect it properly. And when I inspect the pads, it looks to me like they've all soldered quite nicely. I wasn't quite sure about the last leg on this side. So yeah, I just went over and tinned up that last leg with the soldering iron just to make sure it's definitely making a good contact. Okay, so we got the motherboard back out now, and I'm just chatting here about, I can't quite remember what was happening with the current last time because it's been a few weeks since that chip arrived, but I'm going to plug it in again and test it and see what current draw we get and if the chip heats up. So as I plug it in, I can see the current is rising, and we're nearly at 142 milliamps on there, so something is still taking amount of heat. So I'm just putting my finger on there now and seeing if that chip, but it doesn't appear to be getting hot anymore. So let's get the thermal cam out and let's check exactly what is heating up. So when I come with the thermal camera, I can still see that something is heating up in the same area on there.
which was a bit strange. So I'm going to get the macro lens and check, zoom in, see if that's still that chip that's heating up. So with the macro lens attached, I can see that that chip is no longer heating up, but I definitely have a hot spot, which is quite dispersed. It looks like it's now coming from the other side of the board. So I'm going to flip the board over and have a look on the other side. And yeah, I can see something is heating up around there. So it looks like we've got a bit of a heat signature on the big chip, and also to the left of it there's something heating up, and it's kind of a weird signature of the heat on there. Looks like the whole layer might be getting heated up, and possibly a small component there. If I go right up close to it, it looks like there might be like a capacitor heating up to the right, and then some kind of like weird, as I say, area to the left of that. Now I'm just using my finger around here to see if I can feel any heat, and I do feel a slight bit of heat coming from that main MPS chip, but more towards the top left corner of it where that capacitor is, similar to what I saw on the thermal camera. So I think I'm going to use a bit of alcohol now just to see what that does. So coming with the alcohol on here, and to me nothing really seems obvious. I can see it seems to be on the left hand corner of that big chip. It has dried up quicker, so that's not a good sign. It could be an indicator that maybe we've got a chip problem on there. So I see Andy Page has just subscribed, so thank you. And I'm checking, and it's actually a resistor, not a capacitor. When I'm checking close up, that seems to be. The capacitor next to it is slightly hot, but that resistor is definitely hot, and I'm guessing that's not really going to be shorted to ground, a resistor, so it's likely that it's just, you know, a lot of current that's going through that resistor that's causing it to currently heat up. And in a minute I'm going to realise that my mic is switched off, so I'm going to switch it back on and we'll be over to the mic again. Oh no. Okay, we're back on the microphone now. So it was this resistor here that was heating up, and yeah, it's not going to be heating up because a resistor gets shorted, like shorted to ground. It's going to be because there's a lot of current flowing through it. So I'm just going to take a check on this capacitor here. Let's check that in resistance mode and see on that nearby one what we're getting in resistance. Yeah, so that capacitor there is measuring about 6 ohms. So maybe that's the one that goes to that CPU. What did we say the coils were to ground on the CPU? Okay, so that's the one we've replaced there. That coil is about 9-10 ohms. So yeah, why 6 ohms? Just going to check the capacitors around here. No, I can't find my 6 ohms anywhere. Yeah, so it could quite well be because I can see this chip is also heating up on the corner as well, where the that resistor is heated up. So it could be that this MPS chip has internally shorted, but I'm definitely not going to be able to have time to order a new one of these. But there could have been some kind of catastrophic fail in here. I mean, the purpose of the MPS controller is it's controlling these 3 MOSFET drivers here for the CPU. So, you know, this one obviously was definitely heating up, and we've replaced that one, and it's not heating up anymore. So it could have blown this one as part of its failure, and maybe itself is failed as well. So I'm not really sure at this point if I can take this much further, because I want to release these videos one per week, and if there are some like this that are going to be a bit more of an involved fault, then certainly we will revisit these on a live stream, and we can all have a little go together. So if you've got any ideas, let us know. I mean, we've obviously got 6 ohms in the capacitor that we're checking there, so we could certainly inject in there. We could remove this chip and see if that short goes away, and we could also order one and replace this chip as well and program it. So we've got loads of options available to us. So yeah, maybe we'll revisit this in a live stream. I'm really happy though that we've had an interesting one already with this laptop, and you know, we've still got this one to work on as a future project as well, so I'm really pleased about this. So if you want to do your research at home and then join me on the live stream, you could maybe look up the schematic on here. Remember, this is the board number if you want to take a screenshot of it. And yeah, we will have a look at this. I'll probably just order up one of those MPS chips as well, and then we can see if at least if we can read the program off it, because I do have the MPS programmer as well, so we could definitely try and rip the firmware that's on that chip and program a new chip as well and see if there's any change in behavior. I'd be really excited to do that, but it's a very time consuming thing to do right now when I've got a lot more videos to get these out, you know, one per week if possible. So hope you don't mind that, and yeah, we'll visit this one and have some fun together on it. So this is definitely turning out to be a roller coaster ride with this laptop. I thought they were all going to be plain sailing, but hopefully that's not the case, and we're going to have some interesting ones. I'm going to start filming on the next one now, and I'll see you there in the next video.